So continuing on, we're now going to show how to apply completable futures to the ImageStreamGang implementation. And so you'll get to see how this works. And we'll focus in particular here on the use of the factory methods and the completion stage methods. And in the next part of the lesson, we'll talk about the arbitrary arity method, the all-log method. All right, so let's take a look and see how this works. Let's kind of peek under the hood a little bit more. So here's the actual code. And as usual, this is the process stream hook method. Remember, this is the method that's called back by the framework. That's the StreamGang framework. So this gets called back. And what this does under the hood is it integrates the streams, in this case a sequential stream, with the completable futures. Why do we not use parallel stream here? What's the reason for using a sequential stream? Anybody want to hazard a guess? Joe? Exactly, right. So all the stuff here like download image async and apply filters async and so on, those are already doing asynchronous stuff. So it's probably overkill to have yet another layer of parallelism. Now, of course, you know, since your mileage may vary, it isn't hard to experiment, right? You could try writing a version of this that says parallel stream instead of stream and see if you get any kind of a speed up. The one place you might get a speed up is that filter would then run in parallel. So you do the filtering in parallel. But at some point, you know, it's not necessarily always a win to have lots and lots and lots of really tiny little things running in parallel because you don't actually get a win. So, but the point is you can easily change and switch back and forth. And you should hopefully remember by now how to dynamically switch between a sequential stream and a parallel stream simply by passing in a Boolean and then calling the parallel keyword on the base stream instance if you want to conditionally turn it on and off. So it's really easy to experiment with this if you want to play around with it. All right, so the first thing here, of course, is the factory method that makes a stream. That's kind of boring. We know how to do that. We then know how to apply filter. That's exactly like what we had in the parallel streams version. And this is what the code does. If you recall, it goes ahead and checks to see if there's already a file with that name that's been downloaded. And in that case, we assume that it's been downloaded, so we can skip over it. Here's where things start to differ. These are the two operations that use the async behaviors, not the sync behaviors. But notice again, they're called in the context of streams. So there should be a little bit of familiarity there. And you could write this application without using streams, by the way, but it would just get more tedious because you'd have to keep track of all the stuff, and you have to write loops to do all this. And it's quite doable, but it's just tedious. So let's take a look at how we do the map operation. So map is going to call download image async, which, as the name suggests, is going to asynchronously download each of the URLs that's in the stream that comes into map. So that's, of course, why map is an aggregate operation, because it's going to do an aggregate set of calls to download image async, one for each element in the stream. Okay, so what map returns is it's going to return an output stream that has a completable future for each downloaded image. So at this point, that image may or may not actually be downloaded. It all depends on how fast you can download stuff. But most likely, it hasn't completed yet. So let's take a look at what the download image async method looks like. So what it does is it calls the supply async factory method, which, as you recall, is going to take a supplier, which in this case is going to be a call to download image. And this download image call is going to be called in the context of a fixed size thread pool executor. Right? So this is also, by the way, a little difference between this version, which is called Completable Futures 1, versus Completable Futures 2. And I'll explain that in a second. So what this does is we pre-allocated an executor. And what our executor did, we knew ahead of time roughly sort of the max number of images we would be trying to download, because we know the count of the images, let's say 12 or 10 or whatever, and we know the number of transforms, let's say 2. So we simply multiply the number of transforms times the number of images we're trying to download, and then we made a fixed size thread pool that was that big. So let's say it's 20. So we make a fixed size thread pool of size 20, and now we're going to be able to download the we're going to have a pool that's big enough to download them all. So there'll always be enough threads. So that's what this particular implementation does. And so we make our own custom executor. Actually, it's just a fixed size thread pool executor, but it's something that we're going to pass in as the second parameter to supply async. If we don't pass in an executor as the second parameter to supply async, which pool will be used? The common pool, right? The common pool. And what is the type of the common pool? I'll give you a hint. Starts with F. Fork join, right? So the common pool is a fork join pool. And remember, the common pool has this characteristic that if you don't take matters into your own hands to some extent, the common pool could quickly run out of threads because they're all shared, and it starts out with about as many threads as there are cores, or what the system thinks there are cores. So if we were to use the common fork join pool implementation, which we do in the second implementation that I'm not going to show you here, then we would probably want to use a managed blocker call here, as opposed to just calling download image directly. And that's because, if you recall, the managed blocker will temporarily expand the number of threads in the common fork join pool so that we always have enough things to do. We could also set the system property, if we wanted to the max amount as well. Both those things are doable. This approach just sidesteps the whole issue by using a fixed size thread pool that's pre-allocating enough threads to handle the number of images we're downloading. And that might be faster. You know, it might not be as resource economic. You know, it might use more threads than we always need, but it will probably be a fast way to do things. Okay. What each call to download image async returns is a completable future to an image. And of course, that future will complete or trigger when the image is done downloading. In other words, after this call finishes here. And that simply is a call that's a supplier. And so supply async will essentially put that lambda expression into the thread pool. That's the executor's thread pool, which is the fixed size thread pool. When that guy's turn gets to run, he runs. And when it's done, the future will complete, which will then trigger it for the next stage. Okay, so that's basically kind of the factory method part. We're spawning something here. Let's take a look at the completion stage methods. So in this case, remember, we're getting back a stream of completable futures. And we want to be able to then convert that stream of completable futures to images, once they finish downloading, into the transformed images that have had the filters applied to them. And so we're going to call this method apply filters async to filter and store each downloaded image after it finishes downloading. And I think I mentioned before why we use flatmap. We'll talk more about that. So this does the filtering and storing, and this does the flattening of the stream of streams to a single output stream. All right, so let's take a look at apply filters async. So this is a very interesting method, and it uses then apply async and then apply in order to be able to do all the processing. And so let's take a look and see how all this stuff works. And you can find the implementation here. And if you click on this link, it'll expand to the GitHub directory that has the implementation of this. All right, so first of all, the parameter that's passed to this method is a completable future to the image that was downloaded or started to be downloaded in the previous stage, in the map stage, right? So the download image async method returned a completable future to the image, and that is what's being passed in here. We then have a pair of completion stage methods, and you can see that these completion stage methods are being called in the context of a pair of stream methods. So let's take a look and see how this is all going to work. So what we do is we take our filters and we convert our list of filters into a stream. And let's say we have 2 filters to make it easy, but it could be n. And the first thing we do is we're going to create a completable future to a filter decorator with image object for each filter image combo, right? So we have a filter that comes out of m filters. That's what comes in here. And we have an image, and we'll talk about where we get the image in a second. So that's what we're going to do. We're going to make a filter decorator with an image, and we're going to use that in order to, well, actually, we're just going to make one of these things, and then we're going to use it down here. All right, so let's talk a bit about this. This is kind of a mouthful. If you look at the code up here, it's a little bit complicated. What we do is we say, when the image future has completed, in other words, when the image is downloaded, then apply this lambda expression, right? So this code in here, this code, is not going to get called until this completable future is done. So when this completable future finishes, then we're going to apply this lambda expression. And you can see at that point, we have an image, which is the image that's associated with the image future. And then we make a filter decorator with an image with the filter and the image. And this is simply just a simple, good old factory method that makes something, in this case it makes an object, that knows how to download, knows how to transform the image and store it. Yes, Andrew? Well, it wouldn't work in the way we want it to work. What we want to be able to do here is we want to start the stream, and then as, remember at that point there'll be a bunch of different things that are happening, one for each transform. And also, by the way, we could make this a parallel stream, which might actually be a smart thing to do, because then this thing would run in parallel. But I'm not sure. We'd have to look at the code to see if it would even make sense. It might end up requiring blocking, which is what we don't want to do. So the nice thing about this way of doing it is it doesn't block until this particular future has completed. That's the big win here. So what this thing is doing, remember, then apply is typically intended to be used with synchronous calls that return something relatively quickly. And this is just making an object that combines an image and a filter. So we now have a filter decorator with image object. And then this piece of code down here, which is after, it's the next stage in the pipeline, this is going to take in the filter future, right, which is what comes back here. This returns a filter future. And when the filter future is completed, then it's going to go ahead and store the image in an output. It'll filter the image and store it in an output file. So let's take a closer look at this. This is kind of interesting piece of code. So what this is going to do is this says, when the filter created up here completes, and by the way, this will complete pretty fast because it's just making an object. It says, when this thing is done, which should be very quickly, then apply this lambda, actually it's a method reference, apply this method reference in one of the threads in the executor thread pool. So what that's going to do is it's going to take this method reference, and then when this filter future completes, it will go ahead and run it in this executor. So that will actually be running asynchronously. It'll be running in the background when it runs. And of course, it won't run until this future completes, but this future will complete very quickly. And this also then returns a new completable future that will trigger when the image has been filtered and stored. And that may actually take a little bit of time. Why would it take a little bit of time? Because we have to apply the filter, which requires touching all the bytes in the image. And then we have to write that filter to the output file. And any time you do output, it's slower than making an object, for example. So this will take pretty much no time at all, because it's a synchronous call that finishes rapidly. This may take a while, and that's why we run this guy asynchronously in a thread in the thread pool, whereas this thing is going to run in whatever thread happened to be the one that called the then apply completion stage, which was probably coming from a pool, most likely, almost certainly coming from a thread in the executor pool. But this will finish quickly, so we don't want to put it in its own thread. There's no need to. It's just overkill at that point. Okay, any questions about that? So what gets returned here, then, is a stream of completable futures to images which are in the process of being filtered and stored. And then the flat map operation, which is the thing that's ultimately calling apply filters async is going to take the stream of streams, right? Because it's going to have a stream of streams, because each call is going to return a stream, because it may have n transformed images in it, transformed and stored images in it. And it's going to go ahead and flatten all that stuff out. So we just end up with a single stream of images to work on henceforth. Okay, any questions about that? Now, again, this is not unlike your assignment number 3. It's not quite like your assignment number 3. There's differences, but it's much along the same lines. And the architecture is very similar. So if you want to have some fun, try, going back to your question, try playing around with your assignment number 3 and see, actually, yeah, try to see if you can munch it to not do it the way I'm doing it, but doing it the way you were suggesting, and see what happens. Okay, so that is the end of that discussion.